Today we're going to be studying the factors that influence climate. We've already learned about a little bit about weather and climate. We know that climate, you're going to be looking at the temperature and the precipitation no matter where you are. But these are the factors that might influence your climate to be the same or different from areas around you. All right, there are 5 factors that influence climate that we're going to be talking about today specifically. The first one is latitude. That's your distance from the equator. If you start at the equator, your latitude is 0. If you go up, you're moving toward 90. If you go down, you're moving toward 90. So up and down, you're increasing your latitude, whether you're going north or south. Latitude is a big factor that influences climate. Your second big factor is the closeness to a large body of water. Being close to a stream, a small lake, is not going to affect your climate, but being close to a large body of water will. Closeness to a mountain, specifically which side of the mountain that you're on, will be affecting your climate. There are going to be 2 sides of the mountain that we're talking about. And depending on which side you're on, affects your climate. Elevation. We've talked about elevation. It's the distance above sea level when you're climbing up a mountain. Okay? We know altitude is going up in the atmosphere. Elevation is going up a mountain or other fixed object. And finally, ocean currents. That's a pretty simple one, but we're going to be looking at ocean currents and how they can affect your climate. The first factor we're going to look at is latitude. And remember, we start at 0. And whether we move up or down, we're still increasing latitude. So as latitude increases closer to 90 degrees, the temperature is decreasing. We know as we get closer to the North or South Pole, it's getting colder and colder. So that is increasing latitude. We know 0 latitude is the hottest. That's our equator. It gets the most constant, direct sunlight all year round. Here's a great example of surface temperature. So you can see in the middle where we're at 0 degrees latitude, we've got a lot of warm water. It's warm in this area. As we go higher in latitude, we can see that the water temperatures are getting colder and colder. So these are going to affect our climate. Okay, we're going to be talking about the closeness to large bodies of water and how they affect climate. When we're talking about a large body of water, we're talking about oceans, large seas. We're not talking about lakes, streams, things like that. We're talking about a large body of water. So water actually does something called moderating the temperature. Okay, when you think about a moderator, what they do is they keep things kind of even. They keep everybody on time. They keep everybody on topic. That's kind of what the water is doing. It's saying, I'm sorry, you've got to be a little more even. So it means that your summers are going to be a little cooler than areas inland, and your winters are going to be a little bit warmer because your extremes are going to be moderated. Okay? You're not going to get super, super hot and super, super cold like in inland because you're getting that influence coming off your large body of water. So it's going to even it out a little more. If you look at city A, you see you have a large spike going down in January, and then June, July, you've got a large spike where it gets hot. So you've got extreme temperatures. But if you look at city B, you can see it's a little more even. So we know B is closer to a large body of water. because it's more moderate. It's a flatter line. You're going to have a little bit cooler temperatures in the summer and a little bit warmer temperatures in the winter. That doesn't mean you're going to have a warm winter. But instead of being 30 degrees, your winters might be 45 degrees. It's just going to make it a little bit nicer to be there. All right, here's a really good example of a coastal and inland. So right here on these coastal and inland cities in California, if we go across, again, we're at the same latitude. So we would expect all the temperatures to be the same because we're on the same latitude. But we can see the ones on the coast or coastal cities have a lower average temperature, 68, 62, 64. When we go inland, we don't have the influence of that coast, of the water, so our average temperatures are much higher. These temperatures are taken at the same time and are at the same latitude, but we see Monterey is 62 and Fresno is 93. Because we don't have the influence of the water, we have much more dramatic differences in temperature. Here's a good example. We've got a coastal city in Iceland, and we've got an inland city in Russia. So we can see the coastal city in Iceland has more even temperatures. It's still cold. Okay, it's still really cold, but it's much more even. These are on the same latitude. When we go over here to Russia, we have really high highs. It's still cold because of our latitude, and really low lows. Where the ocean is moderating it, their lowest is around 0. The lows over here are -40, so much more dramatic temperatures. Okay, our next one is closeness to the mountains. Okay, this one is kind of easy to remember. You can remember windward is wet. The windward is wet. The leeward is dry. So what happens is I've got moisture in the air. We call that humidity, and I measure it with my hygrometer. I've got all this moisture in the air. And we know as we go higher in the troposphere, the air is going to get cooler. And we know as air cools, it begins to condensate. When it gets heavy, it precipitates. So I've got all this moisture coming up the mountain. It gets cooler. It starts raining and snowing. So it's like it's empty in its bucket. It gets to the top, it's got a little left that it empties out, but now the bucket's empty. So as it goes to the leeward side, there's no moisture left. It's rained itself out. It's emptied the bucket. There's nothing left. So you have a wet side, the windward, and you have a dry side, the leeward. Because as that moisture rose up, it released from the clouds and precipitated. And now, again, there's nothing left to precipitate. So a good picture here. So we've got the warm, moist air rising. We've got the wind carrying that warm, moist air. As it gets higher in altitude, it gets cooler. It rains itself out. And so this side, we have a dry. And it's also called the rain shadow. So another really quick illustration. We can see the inches are really high on this side. But as we get further and further away, we've got less rain on this left side. So we're in the rain shadow. So as you look here, we've got the Adirondacks and the Catskills up here. So we've got the windward side is receiving a lot of moisture. As we cross over the Adirondack and Catskills, we've released our bucket. We've emptied our bucket. We've got no more moisture. And so on the other side, we have very little precipitation. There's not much left. Same down here. So we've got our windward side. We're having rain here. As we go across the mountain, we've emptied it. There's not much precipitation left. We've gotten all dry, so we're in the rain shadow or the leeward side. All right, this one's a pretty easy one to remember because if you think about a mountain and you look way, way up at a mountain, the tops of the mountains often have snow on them. And they have snow on them because as the elevation increases, as I get higher and higher on the mountain, the annual temperature decreases. So I can live right here at the base of the mountain, and my average temperature could be about 23.5 degrees Celsius. Again, I'm on the same latitude, okay, but different elevation. So if I live up here, just on top of the mountain, my average temperature goes down a lot to 10.5 degrees Celsius. So again, if I live in the valley, I'm going to have a warmer overall climate than if I live high on the mountain with my goats. So we can see as we go higher in elevation, the vegetation changes because of the temperature changes. For about every 1,000 feet we rise in elevation, our temperature is going to drop about 3 degrees. So we start out here at 90 degrees at sea level. Again, if we're in the same closeness to water, we're in the same latitude, we're in the same, general region, if our elevation is higher, it's going to have a pretty big impact on our overall climate. Because the higher we go, the lower the temperature. And this just kind of reiterates it because we know in the troposphere, the temperature decreases with elevation. So this is a nice infrared or temperature map of Alaska during the summer. And we can see that the temperatures or overall temperature of the climate is greatly controlled by elevation. So if we look here, we can see it's really cold. We're talking about 26 degrees Fahrenheit in the summer because of the elevation. We can see that this is a mountain range. There are no mountain ranges right here. This is going to be your flatland. You can see these are very cold. So we can tell by this temperature map that these are going to be mountainous regions, the Brooks Ranges. And these are going to be our lowlands. So we can tell easily from our 48 degrees all the way to our 63 degrees that the temperature variation between the elevations is pretty dramatic. All right, the next one is how do the ocean currents affect the climate? This is a pretty easy one. If you have a warm current, you're going to have a warmer climate. If you have a cold current, you're going to have a colder climate. So if we look here up off the coast of California, we see a cold current, which means even though it's on the same latitude as Florida, it's going to be a cooler climate than Florida because Florida has the Gulf Stream, which is a warm current. Down here, we can look at Africa. One side is going to be cooler than the other side. So our eastern coast is going to have a warmer climate than our west coast because of the current. Again, same latitude, same elevation, but different currents. So we can see here, our warm currents bring warmer climates. Our cold currents bring cooler climates. So the Canary is going to bring in a cooler climate, but the Gulf Stream is going to bring in a warmer climate. The California current is going to be a cooler. where the North Equatorial is going to be a warmer. All right, so here we see the Gulf Stream, which is a warm current, and that's going to moderate the temperature right here on our east coast. It's going to make it a warmer climate. As we go higher, we've got a colder current coming in, and when they mix, you've got that middle. So the currents, the ocean currents here are going to influence the climates closest to that large body of water. All right, so show what you know. Our 5 factors that influence climate are latitude, closeness to water, closeness or which side of the mountain we're on, elevation, and ocean currents. Those are our 5 major factors that influence climate. We're still looking at precipitation. We're still looking at temperature to determine the climate, but these factors can influence or change the precipitation or change the temperature. For instance, elevation is going to make the temperature colder. Windward side is going to make the precipitation higher. So weather differs from climate in that weather is the local, short-term condition of the atmosphere, where climate is the long-term average over a region. And finally, why is understanding how climate forms important to our lives? Well, a lot of people have different opinions, but my opinion is it tells me where I'm going to go on vacation. I want to look at climates to see if I'm going to be somewhere nice that I can enjoy myself, or am I going to be stuck at the hotel all day because it's going to be raining. Now, there are other things. If I am a farmer, would I want to live on the windward side? No. Probably not, because the the leeward side's not going to get much rain. So I want to live on the windward side so my plants get watered. Okay, if I'm going to open a scuba shop, would I rather do it at a low latitude or a high latitude? Low, because I want to be closer to the equator where it's warmer and my friends can enjoy scuba because the water would be warmer.